Closure problem 4-110, solve each inequality and graph the solution on a number line. Whenever I'm solving an inequality, I start by pretending that the inequality notation is actually an equal sign to find my boundary points. So in part A, I see I have a quadratic. Hopefully this is factorable, otherwise we'll need to use the quadratic formula. So I have x squared, negative 15 multiplies to get negative 15x squared, adds to get negative 2, while negative 5x times positive 3x is negative 15, and if I add, negative 5x plus 3x, I get negative 2x. So now I can fill in the rest of my box, my area model, and pull out my factors. So I know x minus 5 and x plus 3 are my factors. If this was actually equal to 0, I would do the zero product property. So I'm going to do that to find the boundary points, which gives me x equals 5 and x equals negative 3. So I'm going to use a number line to actually determine where my solutions fall. I always like to put 0 on there to get my bearing. 5, and the next point I want to go to is negative 3, because that's the other boundary point. So let's look back at the original equation. This symbol is not equal to, so my boundary points are going to be open dots because I can't equal them. Let's test some regions. 0 is in the middle here. So if I plug in 0 into the equation, I have 0 squared minus 2 times 0 minus 15 less than 0. Yes, negative 15 is less than 0, which means 0 would work. And that's between negative 3 and 5. So I can shade in between those points. Now I just need to write my answer as an inequality. Negative 3 less than x less than 5. So I need both my number line and my inequality. And that's A. So for B, similar process. Let's first pretend that this is equal to 10. An absolute value always comes out positive, meaning that's what's inside the absolute value can either be equal to positive 10, which will come out to be positive 10, or it can equal negative 10, which would come out to be positive 10. So if I solve these, I'll find my boundary points. X equals 4 is one of them. And negative 8/3, which is the same as negative 6 repeating. Those are my boundary points. So let's go to our number line. I'd like that 0 is between here, so I can put 0. So I'm going to plot my points. I see an equal to sign in the original equation. So they're going to be closed dots on 4 and negative 2.6. I didn't actually give that value on my number line, so I'm actually going to put that there, negative 2.6 repeating, or negative 2 2/3. Let's test 0 because that's in between here just to see if that would work. So 0 in my equation, 3 times 0 minus 2 in the absolute value. That gives me 3 times 0 is 0, minus 2 is negative 2. Absolute value of negative 2 is positive 2. No, this is not greater than 10. So that means 0 does not work, and I cannot shade in between the boundary points, but I can shade on the outside. So let's just write our inequality. X here is less than or equal to negative 2.6 repeating. Here, x is greater than or equal to 4. And there's my solution to that inequality. And yes, you do need the number line to show that solution.